Hello? Are we here? Sound check. We got hit on the Joni Rotten channel. They don't want me sharing. I was playing a song. I didn't think that it was that big of a song, but apparently that person is probably AI generated and I got smacked within milliseconds. So fair enough. I won't share your shit then. All right. They don't want it attached to these articles. Okay. So I'm going to read this article. This is coming from 1981, March 11th. That's what that says. Yes, March 9th, 1981. This is the cover of the Time magazine that I'm going to be reading. It's got Shaping Life in the Lab, The Boom in Genetic Engineering, 1981, Genentech's Hubert Boyle. One thing that I want to note is that in 1981, if you go and you are someone who's interested in genetic research, you will notice that this is the year that is often cited. So in 1981, the genetic condition that I have was found and, published and so forth and so on. It is a very popular year for genetic engineering. And it's in this, captured in time as a time capsule. Prince Charles also picked a bride that year. Okay, so we're going to go to the article. So I'm going to get to it here. Read through to the article somewhere around here. No more free ride for union officials. Oh, that sounds interesting. We got a propaganda sweepstakes, siege, no way to treat a lady, and some coup that failed. But right here, after the American Airlines, look at that beautiful ad. That's gorgeous. And some cigarettes. We get to somewhere right here. Next page. Nope. I found it a minute ago. Why didn't I keep my finger there? Here it is. Shaping Life in the Lab. So I'm just going to read through this article. This is a cover story. You can see the images there. We've got a young man with some 80s hair in front of some kind of cool looking machine. Here is a lady with a bunch of little vials. And of course, everyone recognizes that cryogenic freezing tank. So let's read this, especially everything we know today. So I think this is a kind of a fun way to share this article and then have a comparison. What was going on? What was this? 43 years ago? 43 years ago? 40. Is that correct? But yes. All right. Shaping Life in the Lab and Profiting from Gene Splicing. Oh, this sounds so much fun already. The whole affair left Wall Street slightly dazed. Within minutes, the new stock leaped from its offering price of $35 a share to $89 as thousands of buyers bid for a piece of the action. Brokerage houses had to resort to strict rationing. When a Beverly Hills matron demanded 100 shares, her broker apologetically explained that he could give her only 2. Such was the speculative fever. When an obscure company named Genentech, came over to the over-the-counter market with a $36 million stock offering last fall. Veteran traders had never seen such commotion over an embryonic company, which had only 140 employees, sold no product to the public, and showed a profit for just 1 year at a rate of 2 cents per share. In fact, Genentech is only one of a growing number of similar companies just coming into existence that offer little more than vague promises of scientific things to come. Oh my gosh, this is fantastic. But what promises? What dazzling things to come? A new alchemy that may one day turn the basest of creatures into genetic gold. That alchemy is already capable of making new drugs like an antiviral agent, Infuron, a possible weapon with which in which to attack cancer. In the future, it may produce vaccines, again, against hepatitis and malaria, miracle products like low calorie sugar, fabulous, hearty self fertilizing food crops that could usher in new green revolution, in quotes, Jesus, fuels, plastics, and other industrial chemicals out of civilization's wastes, mining and refining processes to relieve Malthusian anxieties about a future without sufficient raw materials. Oh my. Hello, Kieran. Hello, Ulick. If you're coming in, will you please do me a favor and share out the stream, because there's not a lot of people sub to this, and of course it takes forever for people to get the notification anyway, and I can't stream on my other channel. They shut me down within seconds, so I'm over here sharing. So if you don't mind to do that, that would be rad. This is a very interesting article. I think everyone would enjoy listening. All right. Such things now seem within man's reach through the commercial adaptation of gene splicing or recombinant DNA for oxyribonucleic acid. It is a genie capable of transforming the world, a genie that scientists hope the world will never want to put back in the bottle. I don't think they could if they wanted to now. This is from 1981. In recent years, scientists have also developed other techniques in genetic engineering. Most aim at modifying the hereditary mechanisms of microorganisms or cells for purposes of research or commerce. Others include the fusion of cells, DNA synthesis, and the creation of hybridomas, long-lived cells that are designed to produce pure antibodies for use against disease. But all these marvels, it is a gene splicing that scientists consider the most exciting, says the University of Zurich's Charles Weissman. He's 50, who last year became the first scientist to make bacteria produce a facsimile of human interferon. Quote, biology has become as unthinkable without gene splicing techniques as sending an explorer into the jungle without a compass. Beautiful. One of the things that it said here was it's talking about, let me see, where was it? In modifying the hereditary mechanisms of microorganisms for cells. The hereditary, that just stuck out at me. And I thought of like Jurassic Park, where they're making it all the dinosaurs are female or something so that they won't have babies. The hereditary mechanisms, what does that mean, right? I don't know. Gene splicing is the most powerful and awesome skill acquired by man since the splitting of the atom. It is an unparalleled exploratory tool for examining and, in the process, changing the complicated machinery of heredity. If a gene of unknown function is inserted into bacteria, it can act as a probe that lets scientists see precisely what it does. By such techniques, researchers will finally speed up the formidable task of identifying, locating, and analyzing every one of the more than 100,000 genes found in the human cell. That's very scary. Already, for the first time, scientists can tailor simple living things. They can do this not just by cleverly mixing different strains, as in the slow and ancient process of crossbreeding roses or dogs, but by directly manipulating the genes. Those tiny command posts of heredity that tell living cells rather they will become bacteria, toads, or men. Thus, a plant or animal might acquire a characteristic from a totally unrelated species and pass that new trait on to future generations. Oh my God. That just makes me think of like, you know how they have like in witchcraft where like the witches turn you into a toad? That's what I just thought of. Can they gene slice me into a toad? It looks that way. I could just get injected with something and suddenly, what, I have webbed fingers, or something. Let's see. Karen says, if we put this gene of unknown function into this bacteria, who knows what will happen? Exactly. Okay. Again, 1981. This article is from Time Magazine, 1981, or it's Time News, because it was a weekly newspaper in magazine form. Often decades go by before scientific discoveries find their way out of the laboratory and into daily life. Because of its extraordinary potential, gene splicing could prove to be a dramatic exception. Developed in the 1970s at many academic centers, notably Stanford, Harvard, and MIT. It is a fast breaking out of the university research centers into the world of industry. To its boosters, it seems certain to be the technology of the 1980s, just as plastics were in the 1940s, transistors in the 50s, computers in the 60s, and microcomputers in the 70s. This short-term possibilities of the new gene splicing companies that may have been overblown. In the field of medicine, the new chemical creations face lengthy testing by the U.S. Food and Drug Administration before they can be licensed. Unless there's a pandemic. The application to agriculture will require a great deal of capital, to say nothing of enormous technological advances, before any plants and products can be turned out with sufficient quantities to transform the world. Says James Watson, who with Francis Crick won a Nobel Prize for unraveling the double helix structure of DNA and ultimately making recombinant DNA possible. He says, let's put it this way. I wouldn't buy gene splicing stock for my grandmother. For the future, he's saying. She'll be dead before this matters, is what he's saying there. But the prospects for long-term growth can hardly be overestimated. One research firm, International Resource Development, Inc. of Norwalk, Connecticut, forecasts an annual market of no less than $3 billion in recombinant DNA products in the pharmaceutical area alone by 1990. Oh, that would be fun to go look and see. Was it $3 billion in 1990? Just 9 years away from this article. Crazy. Says Britain's usually reserved economist, quote, biotechnology is one of the biggest industrial opportunities of the late 20th century. In view of such glowing hopes for doing good and making big dollars, it is not surprising that DNA companies, most of them privately held, are proliferating from coast to coast, particularly in California and Boston, New York, Washington corridor. Even Watson's Cold Spring Harbor Laboratory on Long Island, New York, is planning a research company. Wall Street analysis disagree about which fledgling firms will become the Polaroid, Xerox, or Texas Instruments of gene splicing, or indeed survive the infant industry's inevitability shakeouts and growing pains. But a handful seem to be well ahead of the pack and have attributed wide interest in the fields of both science and industry. And now we're going to hear about some of them. How fascinating is this article? I love this. Hello, William. We have said it before. We said it many times before. We are not just the shepherd's herd. We are their creation. Beautiful. Welcome in, everybody. If you're here, I'd like to state for the record that Karen was first today. Ulick got second place. And William, you take up the third. If you don't mind, share out the stream. I'm on my other channel because they struck me on Joni Rotten. So we're hanging out here for now. So if you find this as interesting as I do, please share this out to your peeps. And hopefully they will find this as interesting as well. Now, I know that I have for several years now been reading articles. I've not read them from the magazines. I always read them online. So this is kind of fun to do it this way. I'm actually enjoying this. So I'll be doing more of these. Don't worry. So let's take a look at some of these Genentech Inc. I mean, these pharmaceutical, or not pharmaceutical companies, but labs that are doing this. It looks like we have 4 of them. So let's start at the beginning. So we have Genentech Inc. It was co-founded in 1976 in South San Francisco by venture capitalist Robert Swanson, 32. Does anybody recognize his name? And the University of California biochemist Hubert Boyer. Does anybody recognize his name? He's 44. Why are we giving them their ages? Isn't that interesting? They're not young, but they're not old. The company now has a staff of 200. It has signed research agreements with several large pharmaceutical houses, including Hoffman La Roche and AB Kabi and KABI, and leads all gene splicing firms by offering half a dozen products, among them several types of interferon, one of which is now undergoing clinical trials. Woot woot. Genentech is also collaborating with another leading drug company, Eli Lilly, on mass production of human insulin. Last week, Genentech announced its latest gene splicing advance. In collaboration with scientists from the University of Washington, Genentech's teams introduced yeast cells to make interferon for the first time. The announcement promptly drove Genentech stock up $7 a share. Excellent. This is also into longevity research, Scientology, all of that kind of stuff is all in this door, in this church here. Cetus Corp. CETUS Corp was founded a decade ago by a physician, Peter Farley. Anybody recognize his name? He's a 40-year-old biochemist. Ronald Cape, a 48-year-old, and Donald Glasser, 54, a Nobel Prize-winning physicist. It uses not only gene splicing, but also other genetic engineering methods to modify microorganisms and produce such industrial chemicals as ethylene oxide, which is for making other chemicals and plastics, ethylene glycol, that's what we use in antifreeze and alcohol, and alcohol. With that, many different lines of interest. Cetus has had trouble concentrating its efforts. The company plans a $130 million public stock offering, possibly as soon as this week. I'm just checking to see what you guys are saying. Hello to each other. Hello, brother. Howdy ho. And not too bad. I'm hanging out. Good as to be expected. I'm alive. Excellent. It's good to hear everybody is doing well. Doesn't that look like a fingerprint right there? It's not. It's a little tiny germ cell or something. It's membrane dissolved. E. coli spews DNA strands. Look at that. Beautiful. All right. So that is that company. What was the name of that company there? That was Cetus Corp. Now we have Biogen SA of Geneva. What would be really cool is maybe after this we can go and look if we're still hanging out, but it would be cool to see what happened to these companies. Have they been absorbed? Who bought them? What have they turned into? Who's interested in their stuff since 1981? Biogen SA of Geneva is a research-oriented firm founded in 1978 by a consortium of businessmen and scientists that included Weissman and Harvard's Walter Gilbert. He's 48, a co-winner of the 1980 Nobel Prize in Chemistry. Last year, it produced the first gene splicing interferon like human protein after sifting through 20,000 different genetic fragments. Is that Schering-Plough and Inco, formerly International Nickel, are major investors. Why are they major investors? Schering-Plough. I thought they made Dr. Scholl's. They do. They make foot powders. Schering-Plough. That's one of their things they do. And I don't know what Inco is. It was formerly International Nickel. I can only imagine. Genexcor. It started in 1977 by molecular biologist J. Leslie Glick, who's 41, to manufacture enzymes and other industrial chemicals through gene splicing techniques. I just want to say, well, I just find that is very interesting that they're putting their ages. I mean, there's a reason why they wanted to include all of their ages in this article. 1981, these are middle-aged men. These are younger men. They're at the end of their retirement, right? These are not old guys. They're not young guys. They're right in the middle, right? And here they're doing amazing things. So I think that that's what they're trying to get across in some kind of unconscious way. I've never seen an article that tells me the age of everybody, but they're saying it here. So unconsciously, it's telling me something. Anybody want to, take a stab as to what they think? Hello, lady. Hi, Suzanne. I think Biogen is still going. Okay, probably. Then Gone. Yeah, they busted me. They didn't like me playing that song. I thought I was safe with an old weird, made in somebody's garage song, or but it was I'm assuming AI. It seems like anytime the songs are AI, they're instantly hit. I mean, it wasn't even a second. So so that's what I'm learning. You either have to have the person literally sitting there with a guitar or you're fucked. So, but that song was pretty old. So I kind of thought it was going to be safe. Clearly not. It was like 13 years old or something. It's like from 2000 and I don't know. It'd been around a minute. Okay. So now we have Genexcor was started in Oh, I said that. Okay. Hang on. I was talking about their, their ages. That's what threw me off. So Genex, which is based in Bethesda, Maryland, also does testing and research jobs for other companies and now has a contract with Bristol Myers to produce gene spliced interferon. A major investor in Koppers Company, that's Koppers, is a chemical and engineering corporation. So Koppers Company is a chemical and engineering corporation. So those are the four main ones. So now it goes on to say, the future of such firms is complicated further by the fact that few businessmen can really understand the science and few scientists can comprehend the business mentality. Most of the new firms are tightly mouthed about their products, and the field is full of rumors that smack of the rivalry and intrigue in the early years of the railroad and automotive industries. There are stories of deposed corporate offices, furtively, furtively arranging private stock sales or disenchanted employees about to break away and start their own companies. Oh my. Foreign banks lurk in the background, waving OPEC dollars. Major drug companies are now exploring the possibilities of gene splicing game. Schering-Plough has bought a 16% interest in Biogen. Other drug companies are setting up their own teams. Gene splicing has also piqued the interest of oil companies that not only seek outlets for their cash, but are also, I got some glare, also intrigued by the energy potential. Standard Oil of Indiana and Standard Oil of California together have a 50% stake in Cetus. 20% of Genentech is owned by Lubrizol, 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 an oil supply company. Even academic institutions like Harvard have considered backing gene splicing firms. So high is investor interest that molecular biologist Norton Zender of Rockefeller University says with a smile, I could pick up the phone and in 20 minutes raise $25 million to start up a new company. Wow. This is the pictures here, DNA molecule rendered by computer in cross section. That's what this image is here. It looks like a face from here. Look at that on the screen there. Got some eyes. Let me see. Let me get my fingers showing up in the camera. There it is. I got some eyes. 2 eyes here. Do you see that? 2 eyes on a mouth. Let me pull my finger back. What do you think of that? Looks like a face. Ooh. Acoustic, right. It had to have been, right. I believe that's the case. It must have been up until now. I'm thinking it must be something else. Okay. Hello. I got to put this bigger because I can't tell if that's an O or an A. Is it Laetia? Laida Tia? Oh man, that's a pretty name. I don't know how to pronounce that. Can I get a pronunciation? That's a beautiful name. I love the way that's spelled. My phone is playing up. Fair enough. We're all struggling today. Okay. All right. So that's very interesting. But anyway, it isn't. It's a little, I'll pull it up here so you can see it. There is the image there of a gene that has been spliced. Isn't that beautiful though? That's gorgeous. You wouldn't know that. It's a computer generated image. Here is another one. Here you can kind of see the double helix in these images here. Get that up there. There you go. So those are kind of neat. And this is a side view. So this is a DNA molecule rendered by a computer in cross section. And then this is a side view. Computer image illustrated the DNA's spiral structure. Okay. So for anybody coming in, I'm reading a 1981 article from Time News, Shaping Life in the Lab, 1981, the boom in genetic engineering. It's talking about right as genetic splicing is coming out and what was going on with it all the way back then. Then we'll compare notes to see what we have witnessed since. So it says here, I just want to say this quote again. So he says, so high is investor interest that molecular biologist Norton Zender of Rockefeller University says with a smile, quote, I could pick up the phone and within 20 minutes raise $25 million to start a new company. That quick. One additional incentive for all potential investors, last June's 5-4 decision in the U.S. Supreme Court that man-made organisms may be patented. Woo! And now we see where the patent wars started. How fabulous. Because we've seen that, haven't we? We've seen that. How are you going to patent a tomato? I did. And now you can't grow it because I man-made it. But now in the process of man making, I've destroyed any of the properties that a natural made tomato has. And therefore, natural made tomatoes are dead. They're gone. You can't have them. You still have to buy my man made one now. I've poisoned the water. I've poisoned the air. I've poisoned the soil. And now you only have me to rely on. Aren't I a good God? I take care of you. So whatever gene splicing ultimately does in business, it has already created rich opportunities for biologists, long the poor cousins of science. Genentech's co-founder Boyer has become a millionaire many times over, at least on paper, see the box, to create the organisms that may turn those paper profits into real revenue. Biologists with the prerequisite gene manipulation skills are being recruited at a furious pace. Young scientists, the ink barely dry on their PhDs, are being offered $30,000 a year plus a little stock. Senior researchers are getting large chunks out of the new companies. Others are fattening their relatively modest academic salaries by serving as part-time consultants to the new companies at fees of $1,000 or more a day. Remember, this costing $30,000 a year. This was in 1981. And this paragraph here just completely makes me think of all the movies coming out in the 80s, Revenge of the Nerds, etc., etc. Where the Weird Science and all of those were pumping out the nerd related. We even had in the late 90s, remember the, I Heart Nerds and Nerds Are Sexy t-shirts that everyone was wearing. And it was quite a thing. Deserving through the biologists, deserving though the biologists may be, their new role raises a real concern because they're dicks. That's why. I'm sorry. Let me keep reading. Traditionally, university researchers toil in their labs, usually at the taxpayer's expense, doing basic research. That is, research promising fresh insights into fundamental truths about of nature, regardless of the prospect of immediate payoffs. The bioengineering firms, by contrast, must set their sights on quick returns. Will the new allowance between industry and academia destroy the old objective purity of science? Will scientists still freely exchange information or lab specimens, as they have often done in the past? If they know a colleague works for a rival firm, are they going to do these things? It's asking. Will they forsake long-term investigations into nagging questions like the origins of cancer in favor of faster and more lucrative projects that might, for example, produce a new tranquilizer? It was just such questions asked by faculty members that prompted Harvard to decide against taking part in gene splicing firm founded by molecular biologist Mark Ptashne, Ptashne. I don't know how to say that. Even though the venture might have pumped some needed cash into the university's coffers, Stanford's president, Donald Kennedy, a biologist himself, is urging his colleagues to use, quote, caution and deliberation in responding to the flurry of overtures from gene engineering firms. Reason? Potential conflict of interest between pure science and the demands of their commercial employers. Holy shit. That's happened. Letitia. Thank you for stopping by. Letitia. That's very pretty. I like the way that was spelled. They need to dumb us down. That's right. Catch y'all later. See ya. Laters, Letitia. Excellent. Computer generated like everything else, not real, except for the moon landing. That was on film after being bombarded with radiation. That's not CGI. Okay. So here we have a little image here. It says how to recombine DNA. So it's going to show us these pictures. So you're probably not going to be able to see these very well. I'll try to see if I can lower it down for you here. Right. That better? So in this one, they look like pineapple slices, don't they? In this picture here, so we're going to go 1, 2, then 3. You can see the arrows. 4 into 5, 6 into 7, and then 8 over here. So number 1 here, an E. coli bacterium contains a single chromosome and several plasmids, small rings of genetic material. In the second one, after the bacterium is broken open with detergent, plasmids are spun in a centrifuge that isolates them. Number 3, the plasmids are immersed in a restriction enzyme, causing them to open at a specific place on the ring. Over here. With the acid of the same restriction enzyme, I'm sorry, with the aid of the same restriction enzyme, a gene is snipped from a segment of DNA that comes from a completely different organism, say a virus. Number 5, the quote foreign gene is then spliced into bacterium plasmids. So now they're putting it into there it is, thus forming recombinant 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 DNA. I was saying this word earlier. Now it's confused me. That is DNA from two different organisms. So look, now we have a pineapple slice and an apple slice stuck together. And then it says, this is number 7. The hybrid plasmids are inserted into the bacterium. And then in this picture, the cell divides, replicating all of its genes, including the new DNA. And that's what splicing does. That's crazy. Graphics by Dunkin' Donuts. Yes. The donut. And fabulous. All right. So now our next little chapter here about bitter legal disputes. That's going to be a fun one. Do you guys find this stuff as interesting as I do? If you do, please check that thumbs up and share out the stream. Don't forget to subscribe for more and turn on your notifications so that you may or may not be notified when I go live. Let's be real. I'm subscribed to my own self and have the bells on it. I still don't get my own notifications. How crazy is that? All right. I must be in a wave because I'm getting all kinds of phone numbers from people I don't know today. Recently, tell me if this has happened to anyone else. Recently, I was bombarded for about a whole week. You can tell when it happens. But there were several days, so I'm going to guess at least a week, if not more than that, days where every day it was getting 1, sometimes even 2 text messages from strangers saying, hey, what's up? Or another one they use is, I haven't seen you in a minute. And another one they use is, I don't even remember what it was now. I should have wrote them down or like screenshotted them. They were so funny to me. I just delete them. I don't even open them. So I really don't know what they say. But if you're not in my phone book and you're calling me or you're leaving me a message that says, what's up? First of all, none of my friends use that language like that. None of them just randomly, what's up? Nobody says that. I don't have friends like that. So you've got me pegged wrong. And 2, I have so few people that I talk to anyway, that the first thing I would do if I had a number got a new phone was, hey, Joni, this is Steve. I got a new phone. Update your phone list, right? That's what I would say. I would not say any of these other things. So clearly scams. And now today, this is about the 4th call. No, yesterday. So it's about my 4th call since yesterday of just random numbers showing up. Does that happen to anyone else? I'm curious. Hello, David. Welcome in, my darling. You're not late. You're a little late. But we're right in the meat of things, and you can always rewind. So it is a cool article, so you can speed it up if you want to wait. I'm one of those people that I'll just wait till the live is over. I know it sounds horrible, and listen to you on speed. Like you're on crack. William sounds really fun when he's on crack. That's what I do. Let's see. Bitter legal disputes have already broken out. Oh no. The University of California has sued Hoffmann La Roche and Genentech on charges that a line of cells first created in the university's San Francisco labs. Genentech's Boyers was and still is top researcher at UCSF, University of California, San Francisco. That case is, so they stole it, is what they're claiming. That case is still pending in the courts, but another squabble with the university has already cost Genentech $350,000 plus future royalty payments to the school. The money was awarded to the university for work done by one of its own researchers on a hormone that induces human growth. What does induces mean? It creates it, right? A hormone that creates human growth. Am I reading that correctly? It doesn't stunt it, it creates it. Somebody correct me if I'm wrong. I'll be right back. Oh my gosh, Lai is here. Fabulous. How'd you? You know it. Woo! This naughty girl is never behaving. Shoot, I'm hot. So I'm going to turn my fan on. All right. Because that just, again, longevity research. If I can turn it on, I can turn it off. And, as we saw in the early 20s, 2020s of this whole last, 2 decades, or at least 1 decade. How long has it been now? It's probably not even been 20 years. It's been about 10 years since we've had this, trans movement of preventing children from maturing. Is that what this is saying here? They're inducing it, which means they can slow it down. Oh, sorry to hear that, Lai. We'll be thinking of you, but we understand. That's too bad. Okay. All right. So it says the money was rewarded to the university for work done in which one of its researchers on a hormone that induces human growth, which he brought to Genentech when he joined the company. So he brought it with him. Says John Baxter, the school's chief scientist on the project, quote, "I really felt there should be more compensation." Oops. I thought that was crazy, but I didn't say anything. Naturally, most molecular biologists now enjoying the new prosperity point out that collaboration between universities and industries is neither new nor dangerous. Physicists and chemists, they note, have long worked for private firms, not to mention the Pentagon, with a little complaint from the colleagues, except in retrospect over the atomic bomb. These people should not be having jobs. I mean, just that sentence alone has so many bad things in it. Quote, that's Boyer says, industry is far more efficient than the university is making use of scientific developments for the public good. None of that is for the public good, by the way. The sort of efficient cooperation he has in mind is most evident in medicine. In January, doctors at the University of Texas MD Henderson Hospital in Houston began injecting cancer patients with bacterially produced interferon developed at Genentech. Interferon is part of a natural defense system against such viral diseases as influenza and hepatitis. It also seems to act against certain types of cancer, particularly cancer of the breast and lymph nodes. I know that interferon word, Ulick, because that is one that Hustanistic uses quite often. He talks about interferon. Are you recognizing any, because you listen to him so much more than I do. I'm usually listening to him through as a peripheral. Are any of these words familiar to you? Any of these names, universities, etc.? I'm curious. Yeah. And also, let's just note that interference, let's see, where is it? Where was it? Cancer is or has been linked to illnesses, including not just like foods and man-made things, but also through our viruses. So you can, have a virus that can lead. It alters your DNA when you have a virus. It alters you, making you susceptible to other things. And And so here it's talking about, viral diseases such as influenza and hepatitis, all of them in the Epstein-Barr virus door. They're all under that umbrella of EBV, and that includes COVID. So all of those are all herpes simplex viruses. That includes hepatitis, that includes herpes, a lot of sexually transmitted diseases, if not all of them, are in that umbrella. Chicken pox is in that umbrella, measles, mumps, rubella. Those are all in that umbrella. So very interesting there. Um, linked to, it seems to act against certain types of cancer, right? Because if we know that the cancer is a viral induced, that's what I'm saying there. But to date, only extremely small quantities of it have been available, all painstakingly collected from blood cells and other human tissue. Relatively few patients, only several hundred out of the hundreds of thousands of cancer victims who might benefit from interferon, have been receiving the drug. Natural interferon is very costly, up to $150 for a daily injection. Wow, 150 bucks a day. Most of the people get it. Most of the people getting it receive extremely small doses, perhaps even too small to work. The object of the Texas experiment to determine whether bacterially manufactured interferon acts any different from the natural stuff. If the synthetic drug lives up to its billing and causes no harmful reactions, bacterial assembly lines could start producing human interferon in wholesale quantities. And the price may then come down to about $1 a shot. Very good. Let's see. Hello, Retro. Good to see you. Did they make all of them in labs? I probably. Let's be real. They give people bits of them, then give people bits of them. Or bites, they can come from insects. Most definitely, I believe that. If they say that it's crossed species, then it was man-made. Um, any virus that they say, so AIDS is also an EBV umbrella. It came from monkey. We've been living with monkeys and being bit by monkeys long before we had doctors and hospitals and medicines. Okay, we've been eating monkeys, we've been hanging out with monkeys. We didn't have clean sinks to wash our hands after we were exposed to monkey poo. So in my mind, the fact that that even exists and they tell me it came from a monkey is ludicrous. And that means that that monkey was brought into a lab. That blood was drawn. They pulled out a virus from that blood, a virus that acts with the monkey. And then they alter it. And then they inject it into a human. And then they watch and see what happens. I could be wrong. Strike me if I am. But that is what, pretty much my conclusions have been after years of researching these things. Decades, I suppose, at this point now. So that is that. All right. So next paragraph. Another scarce drug now bubbling out of Genentech's stainless steel fermentation vat is human growth hormone. We all know what that is. Used to treat dwarfism. So human growth, HGH, was created, they want me to believe, to treat people who were born with dwarfism. That was its intent. Okay. All right. Only limited quantities have been available. Most of it extracted from the pituitary glands of cadavers. Okay. That's war. So that's what war does. Sure, maybe they're going to hospitals or funeral homes with needles and they're yanking them out. But World War II taught us anything. It taught us that they really love guinea pigs and lab rats. And I can only imagine that wars illnesses in towns and tribes or villages you've never heard of. These all make great places to go and extract from pituitary glands of cadavers. Nobody would be the wiser. In a test of the hormone, 20 youngsters. Now, you could sit here and say, Joni, they don't do that. Okay, but I don't know that. I don't believe anything they say. I could be completely wrong. I have no idea. Maybe they never have. But if I was the bad guy and I would use it. I would call up and say, I hear that you're about to have a war and I need some cadavers for their pituitary glands. Can I send a team of my scientists in to your POW camps? And can I just, like pull out some stuff with a needle? It'll be very, minor. They won't even know. You can strap them to a chair, make it part of the torture. I don't know, but can I have it? And they'd be like, of course. Excellent. You scratch my balls, I scratch yours. All right. That's what I would do if I was a bad guy. So I can only assume they must do that too. I'm sure they have different ways. I'm making a cartoon out of it, but same idea. Let's see. In a test of the hormones, 20 youngsters are currently getting a dose of bacterial produced HGH at London's Great Ormond Street Hospital for sick children. That's their Scottish Rite. Genetically engineered microorganisms are also producing and the enzyme, I'm not going to be able to say that one, urokinase, urokinase, it's there. Can you see it? I'm going to put it up in case anybody is curious and they want to look it up. What is that? Where is it? Right there. Used to dissolve blood clots. Oh, they might need to add some more of that to the Lucy juice. Because weren't we having some trouble with blood clots from the Lucy juice? They might need to get some of that stuff. It's used to dissolve blood clots. The hormone thymosin alpha 1, which shows promise as a treatment for brain and lung cancer, and beta endorphin, one of the brain's own painkillers. Fabulous. Let me see what you guys are saying. We didn't come from monkeys, and no, we didn't. I totally agree with you there. 55,000 a year for daily injections. That's crazy, right? Wink, wink. Fuck dough. It shows up even from the other nights. Read the full. Okay, let me see what you're saying there, Jerry. Hang on. Let me read this first, and then I have to translate it. It shows up even from the other nights. Read the full of the same shit and cycles of shit they're at now. Yep, all. Hello, Jerry. He says, what's up, y'all? Yes, from the other night's read. I got it. It shows up even from the other night's read and the full same shit. Same cycle of shit they're up to now. That's what we're going to do. We're going to read this and we're going to talk about it, compare notes. Planet of the Apes crap films, but it is so they can keep it out there. We're from monkeys. Yeah, they can keep it out there that we're from monkeys, right? Planet of the Apes. Do I have anybody in here that's a huge Planet of the Apes fan? Does anyone kind of like those films? RNA is 33. That is the nastiest Lucy juices that will come in. Who coined the term Lucy juice? The Rotten Kingdom. Yes, I love it. Everyone else was saying other things, jibbity jabbity juice, but no. Actually, jibbity jabbity juice is pretty good. Lucy juice. I liked that name. That's what we called it in here. Mayonnaise. Says Ulick. Jerry, it's me. Your favorite ghost. Damn, he can't see me. LOL. Hi, Jerry. Hello. Excellent. Okay. And David says that she is cosplaying apes. That's about it. Lucy Juice is the best. Okay. Excellent. So I do find these articles really cool. I'm really liking this. I'm enjoying my new hobby of finding old things and sharing them and reading them. I find that very interesting. Oh, here in this picture, a bottle of synthetic interferon worth $250,000. Just this one little bottle. Can you see it there? Look at that. That little bottle he's holding there is worth $250,000 in his hand. Kieran wants to make sure everyone knows that he was not involved in any monkey business. Nope. I'm not cosplaying apes. My human skin's enough cosplaying. I love that. It's a LARPing. Okay. So here it says, where were we? They own brains painkillers. Okay, we got that one. So the drug closest to commercial production by gene splicing techniques is insulin, the hormone that enables the body to burn sugar for energy. Now insulin is directly related to diabetes, as we all know, and diabetes is rampant. All the artificial this and artificial that, and the diets we've gone on, and all of the crazy things, we fucked our whole systems up. I know that in, say, native or indigenous, whatever the correct word is, Indians in America, American Indians have high rates of diabetes because the food that they eat, that was given to them, or brought over, created, made in stores, it doesn't work with their bodies. They're not that far from the original genetic code. And so they're struggling really bad. What the fuck is that? What is that just showed up on my computer? That's very weird. Somebody, translate that into the correct thing. You know what I'm talking about. It's happened to a lot of native cultures and peoples. They have huge problems with diabetes, and I just happen to know that the American Indians are one of them. The indigenous people here, because, and that's what that's what I had learned, was that their bodies do not process the foods well, and so they're struggling. So that's what I think of there when I read that. Last December, a Derby, Kansas housewife, Sandy Arthitone, at 37 years old, became the first diabetic to be injected with bacterially made insulin. It came from the pharmaceutical labs of Eli Lilly, which is spending $40 million to build plants in Indianapolis and outside Liverpool, England, to make human insulin by means of recombinant, that's how it was said, DNA. More recently, other diabetics began receiving bacterial insulin in a test program in 6 U.S. cities. Lilly plans similar trials in Canada and Europe, says one participating doctor, Fred Whitehouse of Detroit's Henry Ford Hospital. These names. Quote, so far, the synthetic insulin appears to be as effective as animal insulin. So instead of using animal insulin, they're now using fake, man-made, lab-grown insulin. And we really won't know what any of these effects on any of these things are going to have until we have a few generations down the line. So you have a woman who's taking injections and she's pregnant, and now we really won't know the outcome of those injections on her heredity, until that child, her grandchild, grows up and begins to have children of their own. So it is such a long cycle that it's very hard to trace back. And that is what gives them, a head start. It's very hard to go back in time and say, to prove that this child has this disease or this genetic defect based off of what their grandmother was exposed to all those, decades ago. And so it's genius, honestly. Lilly and other drug makers can easily meet current demands for insulin by extracting it from the pancreases of cows and pigs. The trouble is that all diabetics on insulin, some 1.8 million people in the US alone, 5% suffer allergic reactions to the animal hormones because it differs ever so slightly from the human variety. Then we shouldn't be doing it. That's their body saying no thanks. And so they're going to make it in a lab. It may also cause some of the circulatory problems associated with diabetes. By contrast, virtually every atom of the bacterial product is identical in insulin made in the body, and so should produce very few reactions. There is, of course, nothing new in harnessing bacteria for human good. Microorganisms have long been used, even if unwittingly, to serve man's needs, from breaking down waste to making alcohol and producing antibiotics. Man began interfering with the genes, at least indirectly, long before the 19th century monk Gregor Mendel discovered the laws of heredity, which foretell how such physical characteristics of the color of one person's eyes and hair may shape, or the shape of their nose may be passed from one generation to the next. Through cultivation and crossbreeding of plants and livestock, that is, mixing genes, humans were able to make the grand leap from nomadic hunter-gatherers to civilized farmers. They continue such tinkering despite the Bible's stern genetic, what is that? Yeah, right. Despite the Bible's stern genetic injunction, that's in Leviticus 19:19 for my number friends. Thou shalt not let thy cattle gender with a diverse kind. Thou shalt not sow thy field with mingled seed. Wow. So clearly scientists aren't biblical scholars. Do they go to church? It's called Scientology. It's not technically a church. I believe it is a cult. So let me see what you guys are saying. Maybe I should punctuate better. What? Great translation. Excellent. Keeping the miss part. Oh, Miss David. Okay. I may return that ring. I do hope you are real and not an alter ego of Kieran. That would be sick, and in a good way, though. So if it, you guys are so funny. I can't cosplay a man. I'm physically equipped for that. Might get names slightly changed to Davina. Everything's a cult. Link up Miss David. Yes. In case you don't know, David's a chick. But I don't know. I don't think you should ever change your name. I kind of like it. I have a hard time because I like Joni Rotten so much. I just want to use it everywhere. I'm like, why can't I just use that name now? Can I just be that person? Like Lady Gaga or Cher? Can I just be Joni Rotten like Lady Gaga? Why not? Who says I can't? They do it. Why can't I do it? All right. So here we are. Nope, we're still going on. We still have, it looks like at least one more page. So we'll continue reading here. We're picking up on the W. What is new is that scientists are now able to manipulate directly the very substance that makes up genes, DNA, makes up the genes, the DNA, often called the master molecule of life. Coiled in the chromosomes of all living cells, DNA consists of only a handful of chemical building blocks: a sugar, a phosphate, and 4 bases. Adenine, ADENINE, thymine, adenine, I don't know if that's right, thymine, and then we got GUANI, 9. They're all 9s. That one's mine. We got an adenine, a thymine, a guanine, and a cytosine. So we've got A, T, G, and C. but its simplicity is deceptive. In DNA's precise architecture, the famed double helix unraveled by Watson and Crick in 1953, lies the secret of how the molecule conveys the message of hereditary from one generation to the next. The twisted double stranded DNA, as frequently noted, resembles a spiral staircase, with each step formed by a pair of bases. Jacob's ladder is what I think it. A always binding with T, G always with C. Oh man, that makes me think of generations. The four corners of the world, the four. Oh, that's beautiful. In fact, because we've got hero and prophet, they go back and forth. They're connected to each other. And you've got, nomad and artistic, and they're an artist, and they're connected to each other in the same way that you had A always goes with T. So it's AT, 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 and GC, GC, GC. In fact, it acts more like a computer tape. Every three steps serves as a code word for one of the 20 amino acids found in all life on Earth. Strings of code words, in turn, provide the sequence for linking these amino acids into proteins, the basic building blocks of living things. DNA thus carries the entire genetic blueprint for assembling any organism, from bacterium to man. Though the double helix helped unlock many of the mysteries of DNA, even more are still unexplained. How do genes turn on and off? Or, in the language of molecular biology, quote, express themselves? What about cell differentiation? At a critical moment early in the life of an embryo, identical cells miraculously, no other word will do, begin to take on specialized roles, from forming tissue for the heart, for example, others that of the liver or skin. Each of these different cells still contains all the original instructions for producing the entire organism, but somehow unneeded genes are switched off. How does this differentiation come about? Do certain genes order up particular proteins that serve as an on and off switches? We've talked about that before, your on and off switches. So, in the things that we've discussed, let's just say that you're healthy and you're fine, and then you get COVID. And then for some reason, a gene gets switched on or switched off. I'm not exactly sure which. And now you have fibromyalgia or long COVID. You have a chronic condition now. That is a switching on and off of genes. The same thing happens with people who are narcissists. So they have, this gene lying there waiting. And if the right environment, the right circumstances are in place, then their sympathy or empathy gene is just completely, it's either never turned on or it's turned off. I believe it's just never turned on. In the case of development in children, it appears that when we have depriving children from things, like, putting them in cribs all day in orphanages and things like that, that it never allows the gene to turn on, because they were never exposed to what it took and what the recipe was necessary for that gene to become active. That's how I would answer, or I would look at that. To answer such questions, scientists and labs around the country began looking for new ways to examine the genetic machine in action. One of them was biochemist Paul Berg, of 54, of Stanford University. Here he is, biochemist Paul Berg, first of the gene splicers. Look at him there. He's pocket protector and his arms folded. One of them, I said that, Berg wanted to study genes of higher organisms, but their complement of genes tends to be dizzyingly complex. Their complement of genes seems to be dizzyingly complex, involving thousands of steps along strands of DNA. Instead, he and his colleagues plotted an experiment involving viruses, which are nothing more than a short strip of nucleic acid, usually cloaked in a wrapper of protein. When they invade a living cell, viruses substitute their own genes for the victim's genes and crank out duplicates of them. themselves. Berg's clever strategy was to exploit this mischief making ability by using a virus to invade a bacterium. He hoped that the new genes from the virus would begin producing proteins, unlike any normally ordered up by the bacterium's genes. In so doing, the quote foreign gene from the virus would reveal their nature. In his source of DNA, as his source of DNA, Berg turned to a well-known laboratory tool known as SV40, short for simian, like the Sims, simian virus 40, so called because it was originally found in monkeys. Oh, okay. Brilliant. Where was I now? SV40's genetic structure is relatively simple. It seems to have no more than 7 genes versus around 5,000 in the cell of the fruit fly and 100,000 in the human cell. Thus, SV40's genes could easily be identified and distinguished from other DNA of the host cell. To insert the genetic material into the bacterium, he used as his vector or carrier another variety of cells called lambda phage. Lambda phage. I'm way down here. Lambda phage. Lambda, lambda, lambda. Revenge of the Nerds. Remember that was their fraternity they were in, or one of the fraternities that's in that film. Still, other enzymes were painstakingly used to create the required mortise. Is that mortise like sticky ends to attach the 2 strips of DNA together. By the time Berg and his team glued all this DNA back into a circle, they had achieved a scientific first. Genetic material from 2 different organisms, in this case, 2 kinds of viruses, had been directly combined by where are we going? Human intervention. Recombinant DNA, or gene splicing, was born. As its midwife, Berg shared the 1980 Nobel Prize in Chemistry. Man, there's something that said a minute ago that made me think of this. Oh, I know. It made me think of all of those videos I saw, or not all those videos, but the article and the videos you see of where in World War II, the Nazi scientists were stitching dogs' heads to other dogs' heads to create 2-headed dogs, which they were also trying on people. I have no doubt. I would have totally, if I have no conscience and I have an unlimited amount of people to do whatever the fuck I want to without any, consequences at all, you better believe I would have said, I want 2 people. I'm going to sew their heads on. Doctor, that's not going to work. Doesn't matter. I want to do it. I'm a crafter. Give me 2 people. And by the way, you're going to the showers because you asked questions. Do as I say. Anyway, let's see. The next phase Berg planned for experiment brought on the hottest controversy that gene splicers have yet confronted. Berg wanted to insert the SV40 genes into the bacterium E. coli. Escherichia coli. Is that what that is? E. coli? Right there. See? E. Is that right? E. coli? Am I saying that right? That's the abbreviated word for that. An inhabitant of the human intestine, only about 1/10,000th of an inch long. It is E. coli. It says right there. E. coli has been the regular guinea pig of the molecular biology lab for some 40 years. But it causes tumors in mice and hamsters and has turned test tube cultures of human cells cancerous. That is so sick that they're doing that. What would happen if E. coli containing the monkey virus escaped from Berg's lab? Oh my God, established themselves in the human gut and went on multiplying? Would that plant a slowly ticking cancer time bomb? Holy fuck. That's what that says. Did it? I don't know. Look at that. Would that plant a slowly ticking cancer time bomb? E. coli? If it escaped his lab? Before we go on to the next section, let me see what my peeps are saying. Oh, let's see. I can? Okay. What are we saying over here? Of course he could be. Okay, hang on. I got to go up a ways. You guys have been very busy chatting. Fair enough. Let's see. That's true. He wouldn't, right? They got the same. That would be very hard to do. You'd have to be sitting there with two things with it typed out and hit enter at the same time. I don't think any of us give enough fucks about trying to trick anybody to waste the time to do that, I have to say. I'm crippled laughing. Oh, man. You know I don't wear any jewelry. Anywhere? I don't like jewelry either. It's true. She does. I feel like I'm learning secrets. Of course he could. He could be like your man Glass with all the personalities. You want proof I'm real? Okay. So you guys are having a good time over there. There you go. You could just be using a voice changer. We wouldn't know. The chain of custody is bad on that one. He's already seen me in a dress too. Fair enough. You guys are so cute. You know the fun things I missed. Except who you are. Just like me. Sticking to the face, the fake beard. Transoperational. Stop the press. Relax. Happily ever after. You guys are cute. All right. So now we're going here. And it looks like this is going to be the end when we get over here to this page. And then we'll have to go back and check out what this one is. Blue chips for a biochemist. I don't know what that is. But Hubert Boyer is eyeing the vial. He's eyeing a vial of DNA. That's what he's doing in that picture. So that's going to be fun to read. Okay. Let's see here. Okay. And I'm questioning my life now. You should. Berg voluntarily dropped the plan experiment. He did all by himself. How nice of him. He decided not to do that with E. coli. But what about everyone else? Do you know what I mean? Concerned about the possible escape of new and deadly pathogens, he helped persuade his colleagues to observe a self-imposed moratorium on such experiments. Even so, some university towns threatened to ban all recombinant DNA work. The voluble former mayor of Cambridge, Massachusetts, Alfred Vellucci, spoke darkly. and inaccurately of breeding. He says Frankensteins in the lab at Harvard and MIT. So he said they're growing Frankensteins under federal guidelines drawn up with the help of scientists led by Berg and adopted by the National Institutes of Health in 1976. Gene splicing in university labs was strictly controlled. The new rules established levels of biological containment deemed appropriate to possible hazards. If a proposed experiment was low on the risk scale, it could be done on an open bench or perhaps on a special counter protected by a curtain of air. More dangerous experiments required sealed isolation chambers like those used in germ warfare research. Only by researching through a gloved compartment did the scientists have access to their work, much like what you see with Resident Evil and the T virus, also Epstein Barr virus or T virus. Yet, even without these precautions, the ultimate safeguard, bacteria especially designed to self-destruct if they escape by nurturing environmental escape the nurturing environment of the lab. Again, these GMO'd mosquitoes that we had that are made to not reproduce, or once certain environmental factors are present, the mosquitoes just die on their own. Like a bacteria, or not a bacteria, a virus left on, I don't know, the checkout counter at the grocery store would die within so many minutes or so many hours, something like that. But they modify them to do that. If they're modifying them to do that, then they're basically changing the structure. And so you can't I don't know, I'm not a scientist, but I would think that if I'm changing the structure so that the item acts a certain way, am I not tainting my results in the first place? Maybe not, but that's what I would think. Yet, even without these precautions, a subsequent test showed that probably none of the doomsday scenarios could have occurred. Last year, NIH dropped most of the restrictions on gene splicing work, so they've done that now. While Berg and his colleagues were agonizing about the possible dangers posed by their experiments, two other scientists were planning on an even more dramatic display of gene splicing. One of them was an intense biochemist named Stanley Cohen, 46, whose lab was only 2 floors below Berg's own quarters at the Stanford Medical Center Research Building. The other was Boyer, who worked just an hour's drive away at the University of California in San Francisco. Their partnership had emerged accidentally. In November 1972, after a long day of listening to scientific papers at a conference in Hawaii, they met in Waikiki Delicatessen for a midnight snack, gossiping about their work while munching on corned beef sandwiches. And the two discovered that their research dovetailed in a way that opened up some highly intriguing possibilities. Almost all of E. coli's 4,000 genes are locked in a single circular chromosome, but Cohen had isolated some bits of genetic material that float freely in the bacterium outside this main genetic repository. These bits of genetic, quote, small change are known as plasmids. A plasmid contains as few as 3 or 4 genes linked in a small circle. Yet it sometimes is crucial to bacterial survival. During normal bacterial reproduction, the cell simply divides, passing exactly the same genetic information on to each daughter cell. Thus, they are natural clones, genetically identical to their single parent. In this kind of unisex production, there is no chance for bacterial to inherit fresh characteristics that might help improve their chances of survival. But every so often, two cells have a sort of sexual dalliance called conjugation. They approach each other, send out thin tubes that bring the cells together, and transfer genes. In the exchange, the bacterium may pick up, say, a gene for making an enzyme that cuts up and destroys certain antibiotics. All the bacterium offspring will then inherit this life preserving resistance, and in this way defy medicine's best efforts to do like to to do them in other words, they find a way. Jurassic Park, life finds a way. Like Berg, Cohen wanted to insert new genes artificially into bacteria, but where Berg resorted to a virus at his transport system, Cohen opted for plasmids, which he had been studying in his lab. As he listened to Boyer's description of his work that night in Waikiki, however, Cohen realized that there might be a shortcut. Boyer and his associates had found a so-called restriction enzyme that cuts DNA precisely at the predetermined points and performs this surgery in an especially helpful way at each end of the severed twin-stranded molecule. It leaves an extra bit of single strand poking out, automatically creating the sticky, mortized ends that Berg had labored so hard to achieve. The twin breakthroughs, Boyer's surgical enzyme and Cohen's plasmids, opened the door to an extraordinary scientific capability. If they were used together, almost any gene, from a virus to a frog or a man, could be sliced into the plasmid. Cohen named this mixed bag of genes a chimera, after the mythological beast that was part lion, part goat, part serpent. Oh, that's so disturbing. Such a plasmid could then be inserted into E. coli, and as the bacteria replicated, the transplanted DNA would be copied down to the last step on the spiral staircase. Any product ordered up by the inserted genes, the antiviral agent interferon, for example, or perhaps an enzyme to break down oil molecules, would also be made in the offspring. And in abundance dividing, once every 20 minutes, the original bacterium would undergo a population explosion. In 24 hours, a single bug could result in billions of bugs, all of them churning out the desired product. At first, Cohen and Boyer balked at seeking a patent for their work, but Stanford licensing director Niels Reimers changed their minds by citing the base of Alexander Fleming's, the British discoverer of penicillin. Fleming had also refused to take out a patent, thinking that this would ensure penicillin's widespread availability. Instead, since no company would take the financial risk of making it without a patent protection, the wonder drug did not go into protection until World War II, some 14 years after Fleming had identified it. Cohen and Boyer's own reluctance was overcome just in time. They signed the patent application only a week before the deadline expired. Any royalties were to be turned over to the universities. For a while, it looked as if there might be no royalties for anybody. The U.S. Patent Office refused to grant this application, contending that new life forms are not patentable. But this view was overturned in last June's U.S. Supreme Court decision. Through the test case involved an oil-eating bacterium developed by crossbreeding techniques, the ruling was also held applicable in gene splicing generally. Cohen and Boyer wound up holding the first patent in the recombinant DNA field, a natural product like synthetic. Make sure you can read this. It's right here. A natural product like synthetic interferon cannot be patented. So what Cohen and Boyer actually did patent was the basic gene splicing method that they had pioneered. Sometimes scientists like James Watson contend, however, the other gene splicers will easily circumvent such legal protection by making just slight changes in their techniques to avoid patent infringement. Oh, man, this story's getting good. What is going on? experimental shit is an ongoing germ research. German. Something about Mary. He has some scars. Scars? Is that all? I'm not sure what the other yolks did. They did get them from a zip. Mickey's Twink. I get what you guys are talking about now. Joni, I have a nickname made up for you. The pair off the Dukes. I don't know if I'm going to use the sexy term, but sure. Can I be Luke and he can be Bo? Because I always wanted to play Luke Duke when I was a kid. That was who I always wanted to be. Anytime we would all pair up, and the few little kids of us in the neighborhood, there was all the girls always wanted to be Daisy, but not me. I said, I want to be Luke. Going to drive the car. Okay. So that is a very scary. So the lawsuit, the patents, we're seeing a lot of that currently. With the patents, we've seen a lot of that happening through COVID, remember? Through, basically transhumanism, COVID, cancer, you name it. She drove a Jeep though, didn't she? Am I back now? Oh no, I just lost connection for a second. I'm back. I didn't know it just went. Bo sounds about right. Where did you go? I don't know. It just disappeared for a second. Okay. All right. Here we go. Let me have a little sip of mine. Does anybody want to come up and chat for a bit about this? I'll open the panel up here. We've really only got about 10 more minutes of reading, maybe 15. And, we'll throw up a discussion about it. I'd love to hear everybody give their opinions and 2 cents. Let's see. There are certain to be more patent lawsuits, but they are most likely to affect individual scientists and companies, not the future of products created by gene splicing. The multiplication of such products, moreover, does not appear in doubt. A new study scheduled to be released this week by the Congressional Office of Technology Assessment lists no fewer than 48 human hormones that may soon be manufactured by minute gene splicing organisms. Holy shit. This was 1981. This will vastly increase medicine's arsenal of drugs. Many researchers, for instance, are working on vaccines for stubborn tropical diseases. Concludes the congressional study. These may profoundly affect the lives of tens of millions of people. One team of doctors has already tried gene therapy. The effort to correct hereditary defects like the blood disease. Yes, thalassemia. I just love it. I fucking love it. I'm so on top of this shit. I've been so on top of this shit. Thalassemia. How do you say that? Thalassemia. Thalassemia. If you were with me in the old days of the Rotten, Joni Rotten, and the what was it again? Joni Rotten Studios. I did a music video talking about thalassemia. Thalassemia is a blood disorder. Do you remember when, was it Max? Yes, Max brought me an interesting story about a Canadian pharmaceutical company owner, the owner of a pharmaceutical company in Canada that was murdered mob style. He was tied to a chair with his wife facing the wall in his pool room, where his swimming pool was an enclosed swimming pool, and both of them were shot in the head, and their house was ransacked. He had an obsession with vampire movies, and he also loved the mob. And his hit was very mob-esque. It was beautiful. It was a really cool video. I had the Scooby Doo, Mr. Jenkins. But thalassemia, he had a rival pharmaceutical company that also was trying to cure thalassemia at the same time. The same time, they were both trying to do it. One was doing it from this direction and one was doing it from the other direction. In other words, one was hitting thalassemia from this side and one was coming at it from the other side. And they were in direct competition, and both of them were set to release their information, and one of them was murdered mob style. Now, why is thalassemia so interesting? Well, thalassemia is directly related to vampirism. It is a blood disorder that causes people to need iron. It causes them to garlic, even though we use it to repel. Garlic is actually something that is recommended to people with this. So it's got all the links to vampires. and the thalassemia, what would they be called? What is it called when they want to bring awareness? Thalassemia awareness uses actors and actresses, a lot of them Bollywood, and they use their images upside down. It's absolutely an interesting thing to look at. And here it is, 1981 in here. Thalassemia, by rejecting abnormal genes with normal ones created by splicing techniques. These initial experiments failed abysmally and were widely criticized as premature until much more is learned about how humans might be made to acquire new genes and how these genes are expressed. Future gene therapists are no more likely to succeed, so they say. Beautiful. A lot of money in curing something like that. Also in the future, but perhaps more, hang on. Okay, Jerry's having dinner. Thanks, Jerry, for stopping by. Come back. Hemophilia is a blood disorder too. Yes, yes. Bon appetit. Good luck, Jerry. Also in the future, but perhaps more feasible, are gene splicing applications in the fields of animal husbandry and agriculture. Under a contract with the U.S. Department of Agriculture, Genentech has already working with a vaccine against hoof and mouth disease, which kills off millions of food-producing animals a year around the world. Geneticists also hope to endow such basic food plants as wheat, corn, and rice with the ability to, quote, fix or draw their own nutrients from the nitrogen from the air. At present, nitrogen must be provided in expensive fertilizers made from increasingly costly petroleum products. Oh. But scientists using plasmids, they make it sound so good. We're going to get rid of those petroleum products. But scientists using plasmids have already cloned some of the nitrogen fixing genes found in bacteria. And in an experiment at Cornell, a complete set of 17 such genes was transferred from bacteria to yeast, a slightly higher organism. The ultimate goal? To insert these genes in plants themselves. Some scientists are already looking ahead to creating bacteria that can help collect scarce metals by leaching or dissolving them directly out of the earth. That does not sound like a good idea. Why would you do that? Or forcing out the last drops of petroleum from nearly exhausted wells, or even sift through diffuse quantities of gold in the world's oceans. Maybe the oceans need the gold. Why would you want to take it out of there? What kind of idiot are you? These people are so disturbing. Like faithful robots, they will work uncomplainingly without interruption or distraction. All they would require is an appropriate nourishment and the right sort of care. But not everyone is rooting for the gene splicers to achieve their goals. Were they to do so, they would possess truly Faustian power. Faustian, Faustian power. I'm saying that right? Not only to make repairs with genetic machinery goes awry, as in such diseases as hemophilia. Oh, we got you there, David. It's there, and sickle cell anemia, but to improve the species itself, to improve me, but to improve the species itself. Peter Thiel shows up. Wink, wink, he says. These aren't quotes, those are winky eyes. There may be pearls in disturbing a microbial balance that has been billions of years in the making with strange man made bugs. That sounds very bad. Ask biologist Robert Sinsheimer, chancellor of the University of California at Santa Cruz, quote, do we really wish to replace the fateful but impartial workings of chance with the purposeful, self-interested workings of human will? Even more dourly, biochemist Erwin Chargaff notes, quote, if you can modify a cell, it's only a short step to modifying a mouse. And if you can modify a mouse, it's only a step to modifying a higher animal, even man. But even Sinsheimer admits that there is probably no turning back. The genie is out of the bottle. A great majority of scientists also point out that no gene splicing monsters, bacterial or otherwise, have escaped from the laboratory. What is more, there is a world of difference between splicing a viral gene or two into a humble bacterium and redesigning the complex genes of man, which now seems quite remote. But you're saying there's a chance. So 1 in a million. So you're saying there's a chance. In any case, an enthusiasm grows for what gene splicing may eventually be able to accomplish. The debate has become moot. Chief Justice Warren Burger himself acknowledged that this when he declared in the 1980 patent decision that no one will be able to deter the scientific mind from probing into the unknown any more than Canute can command the tides. What both the public and scientists can do is to ensure that this insatiable inquisitiveness is channeled to serve the common good. So far, the proud record of gene splicers seem to bear out the hope that it will be. And this was written by Frederick Golden, reported by Michael Mortz, Los Angeles, and Gavin Scott from San Francisco. They did the research on that. What do you guys think? Interesting. Let me see what you guys are saying. Sounds like RH negs blood doesn't accept RH positive blood in the transfusion. It seems to always be dinner time from 5 to 6. Yep, every person I know has dinner at those times. Fair. And then when you guys are doing your after dinner parties, I'm having dinner. What happens when an iron-eating bacteria gets into your blood? Very good question. It's a fair question. Reminds me of the Foucault gain of function. Carry on. CRISPR technology. That's exactly what I was thinking. So, blue chips for biochemist in his faded jeans and an open leather vest. There he is. His faded jeans and his open leather vest. That mustache and that hair. There he is. It's not a joint in his hand. He's not got a joint. Four finger Fred, they call him. And a can of Budweiser in his hand. He looks like a leftover from the 1960s. Back then, in fact, he marched regularly in the streets of Berkeley, California. Oh, he was a Berkeley. Excellent. We all know what was going on in Berkeley during the 60s. He marched regularly in the streets of Berkeley, California, taking part in civil rights and the anti-war demonstrations. Despite his casual look, Hubert Wayne Boyer is a millionaire many times over, at least on paper. And more important, he is in the forefront of a new breed of scientists, entrepreneurs, who are leading gene splicing out of the university laboratories and into the hurly-burly of of industry and commerce. Boyer's success is a result of brains and foresight, plus a strong independent streak. In 1976, after the first flush of public excitement about the gene splicing, Boyle got an unexpected telephone call from Robert Swanson, a young venture capitalist. Swanson wanted to discuss the commercial possibilities of the new science, and many scientists might have kept him at arm's length. Boyer invited Swanson to his lab for a chat, but told him he could only spare 20 minutes. The two hit it off so well that they went on talking over beers at a social pub for nearly 4 hours, recalls Swanson. Quote, all the academics I called said commercial application of gene splicing was 10 years away. Herb didn't. Yielding a Swanson's enthusiasm, Boyer borrowed $500 to join him in forming a company to exploit the new technology. They dubbed it Genentech, for genetic engineering technology. As Boyer explains it, he wasn't happy with Boyer and Swanson, and I wasn't happy with Swanson and Boyer. The motives of the two, so they didn't like naming it Boyer and Swanson, and they didn't like naming it Swanson and Boyer, so they came up with Genentech. The motives of the two were different. Swanson was 28 with a degree in chemistry and business administration from MIT. After several years of seeking out investment opportunities for others, he wanted to show the world he could succeed with a business of his own. Boyer, on the other hand, was interested in getting the new technology out of the lab and using it for some good. To me, genetic engineering means design and development for the benefit of mankind. I'm God. As Genentech's vice president, Boyer pinpointed promising areas of exploitation and, in his words, quote, made sure that the scientists were being taken care of and the particular value recognized. Boyer did his job extremely well. Today, after less than 5 years, Genentech probably has the best research facilities in the gene splicing business. 40 PhDs and 65 technicians. It has produced and is testing half a dozen recombinant DNA products, including insulin, human growth hormone. We've seen that. Geez, insulin, right? We've talked about that, and various types of human interferon. Swanson gives Boyer the highest grade. For an academic, he's got an incredible sense of what's important from a business standpoint. Boyer now draws only a consultant's fee for his Genentech work, but he has not exactly gone unrewarded. For Swanson, he owns 925,000 shares of Genentech stock. Last October, when the stock went up to $89 a share, he was briefly worth more than $80 million. Currently, with the stock at around $43, the figure is down to a mere $40 million or so. Watching the ebb and flow of this paper fortune, Boyer admits it's a little unreal to me. Well, it might be. Born in 1936 in Derry, Pennsylvania, population 3,400, near Pittsburgh, Boyer is the son of a railroad conductor and brakeman. Early on, and is more inclined. He was more inclined towards high school football and then a scholarship. His high school class voted him most athletic. His own ambition, he wrote presently in his yearbook, was presciently to become a successful businessman, he predicted. He also a taste for science, or developed a taste for science, encouraged by his hard driving high school coach, who doubled as a science and math instructor. He went on to pursue those subjects at nearby St. Vincent College, a demanding Benedict school. A few summers of digging ditches and working in local Westinghouse transformer plant helped convince him that, quote, I had better start paying attention to what people are saying in class. For a while, Boyer thought of becoming a doctor, but after assisting at an autopsy, he decided he did not have a stomach for such work. His interest in genetics was awakened almost accidentally when he was asked one day at St. Vincent to deliver a class report on DNA, which had only recently been formally established as the molecule that forms genes. Says Boyer, I got hooked. There was something very beautiful about it. It explained a lot of things. After earning a PhD in bacteriology from the University of Pittsburgh, he did postdoctoral studies at Yale, becoming so immersed in the subject that he named his Siamese cats Watson and Crick. He also became disheartened by public events, the draining agony over the war in Vietnam, assassinations, racial unrest. I thought our political system was falling apart, and I was ready to go somewhere else and live. When he began as a researcher at the University of California 14 years ago, he was paid $10,500 a year and told repeatedly, you'll never get rich in a university. Now that he is a full professor and director of research team, he earns about $50,000 a year. Though Boyle often works late into the night, he sometimes astonishes young scientists under him by dropping everything to watch the World Series on TV. He also likes to fish and ski, and until a year ago, jogged regularly. He has grown chunky since. The only obvious change in Boyer's lifestyle since Genentech's big splash has been the acquisition of a new champagne beige Porsche Targa. Targa? T-A-R-G-A, Targa. $40,000, that's setting back. He is married and has 2 children, but since his sudden riches, he likes to keep them out of the limelight. Even his associates at Genentech do not have his new home phone number. Although Boyer spends no more than 1 day a week at Genentech, that involvement has irritated many colleagues. Some will barely talk to him, claiming that he's profited by research done mainly at the university. They believe it is impossible to pursue pure research and development commercial products at the same time. There is even talk that he's publicized involvement with the Genentech may have cost him a Nobel Prize. But the carping, probably motivated at least in part by jealousy, does not seem to bother Boyer too much. Says he, if you have a strong conviction that what you're doing is right, then you can stand up against a lot of criticism. Well, there we go. He's had the munchies since. So that finishes up our 2 hours of that article. Time, Shaping Life in the Lab, the boom in genetic engineering. I thought that was very good. That was from 1981, and we are now several decades in the future, and in 2024. So what have we learned here? Do we have any thoughts? I'm opening the panel, so if anyone would like to come up and talk about it, I will allow that to happen. What happens? We said that. Reminds me, we said that one. CRISPR technology. That whole hippie movement was full of military offspring. Yes, it was. Hello, Robert. Good to see you, lads and lassies, he says. Hello. Will they only, well, they've only 8 billion of us to keep an eye on. So anyway, that's that. He's a little chubby there, Hubert Boyle. There he is there. That's the same guy we were seeing in his open leather. Is that what his open leather vest? It was really fun. I do like reading these. It appears as if my friends somewhat enjoy this as well. He's had kids today, that guy working in the same. Has he kids today, and is he working in the same field? It's very interesting. Let's go find out, shall we? Let's go see about Hubert Boyle. Let's go over here. Get my keyboard out. Hubert Boyer. Oh, there he is. All right, give me a second. Suspiciously like bear. Let's go over here now. Okay, let's check him out. All right, we're on it. We're going to do it. I'm going to switch to, well, I guess I'll leave it like this. Okay, let's make it big though. Let's check him out. All right, Hubert Boyer. He's an American biotechnician. Here he is now. Oh, let's check him. Let's see. There he is then. Here he is then. And here he is now. Then and now, then and now. Ooh, I'll do it like that. Our founding father. Holy shit. Gentech 40. Our founding fathers. There he is. We can watch him give a story September 19th on YouTube. He's 88 years old. Got all of his stuff there. Looks like a real piece of work. Let's just go to Wikipedia. Let's find out if he sits on any boards or has any, you know, there's his alma mater, his awards, his field. So we kind of read about him, so I'm not going to bother with this. Herb. Let's see. He retired in 1991, so 10 years after this article, it says he retired as vice president. And participated as an activist in the civil rights movement. Well, he certainly screwed us all over now, his career. So there, we kind of read through that. So I'm not going to bother. Of course, it does have some later things. The Boyer Center of Molecular Medicine was named after the Boyer family in 1991. Gave a big donation in 1990 to Yale. They had renamed the School of Natural Science and Mathematics and Computing. They named it Hubert. They had a school named after him. That's beautiful. They love that. Let's see. So here we've got some of his awards. So he's got quite a lot of awards there. Excellent. The CSHL Double Helix Medal honoree. He's got a Perking medal. Look at that. He's got a lot of awards. Look at all of his awards. This one, a Heritage Award. Do we get to see what it looks like? No, it doesn't want to tell us. Look at that one. Fuck the images. Has anybody ever do a video of the symbols from these medical awards? these medical awards people get, because I'm looking at them and I'm like, wouldn't you like to break down that symbolism? Look at that. Look at that. Can I get in there closer? No. Look at that square. That looks like your little, Pink Floyd, your square and compass. Here's another one with the eagle. If nobody's done that, somebody should. One of these channels should. They're always showing me pictures of checkered boards on the floor, but they're not showing me pictures of these and breaking these down. Look at that. That's got that guy's face on it. The Sears, with rope Sears. Where are they involved? We know. Anyway, here we go. Some books, Reshaping the Lab. There's the article we read right there. Oh, wait. February 9th, 2002. Cover retrieved May 17th. Oh. That's not what year this is. So I don't know what that means. From Time Magazine. I'm going to click on it. Oh, there it is. Okay, well, that's an old, I'm looking at it. All right. Let's go back. All right. That's incorrect information here. It's all incorrect. Let's see. Okay. They Made America from the WGBH television series. Yeah, this guy's all right. So let's see what else we can find out about him. Cold Spring Harbor Laboratory. What is biotechnology? There's a little image we saw. PBS, Who Made America? Our founding fathers. Oh, Inventors Hall of Fame. So he sounds like a dick. What do you think? What do you think of Hubert? Imagine getting an award of that cunt Bush. He probably opened plenty bodies. He did. He got the George W. Bush. Jobs for the boys. He's got a great map of hair. A mop of hair, sorry, of 88. Told you I can't see that far. So it's like, is that an O or an A? I'm guessing. Nice wig. Yale University. I know. Well, there you go. Twink needs to tell him to zip up his Mickey fast. There is our biochemist. Well, if nobody wants to come up and chat with me, I'm going to end this. We've been 2 hours now. So I'm going to leave this up for any of our friends that want to come and listen later. You can share this out with people if you found this interesting. Do you want me to do more of these? Let me know. I have plenty of magazines and articles that I think are interesting and I'd like to read. I like to read them in comparison to what we know now, and from our eyes, from our perspective. Lots of channels that do this, but they don't do it the way we do it. And that's why I like doing it our way. I can go listen to 100 other people talk about these things, but they don't do it in our style. That's what makes us really unique here. Fair enough. Yeah, an excellent read. Yes, it was excellent. I'm glad that you guys are enjoying these. So, I don't really know that, there's a whole lot necessarily in this magazine outside of that. When I was flipping through it, there's weird articles and things. I liked reading through that other one the other day. We just kind of read through the whole thing, but it did take a very long time. So I think what I'm going to do, if I have nothing else to do for 4 hours, I might sit and read through them. But I think what I'll do is I'll just pick maybe the cover and we'll read the story inside. If the cover is interesting, I also like the idea of reading through the letters. So reading the original article and then reading through the letters of what people have said about that article. I find that kind of fun. So I think I'm also going to do that as well. Look at that, Walter. Thank you, Walter. And there's that. So much love to everybody. Thank you for coming in and hanging out with us and me. And we shall see you guys later. Find something fun to do. Yes, it's in the evening. Anybody know of anybody going, yeah, that's on the front cover too. Like, you want me to read that article next time? I can come back and read that one as well next time. The story of, I know that we all know these stories, but to have them not from today's, but from when it was happening. It's like the difference between hearing a story from your dad about your grandfather and hearing the story from your grandfather. Do you know what I'm saying? It's that difference. It's hearing it from the horse's mouth, if you will. Yes. Okay. Definitely. All right. I'll leave this on my desk and I'll come back later, maybe tonight or something, and we'll read that article and have a little chitty chat when everybody can kind of hang out. Gen Tech also. Right. Totally. All right. Much love, guys. We'll bounce out. I'll throw the bounce out because it's fun. And it reminds us, no contact is the road to freedom. Don't buy their stuff. Don't listen to their music. Don't go to their concerts. Don't, everything should be old. If you're going to buy their stuff, buy it, something that's going to be tossed away. Give them as little money as possible. There's no way we can do that completely. I'm not going to do that, but as little as possible. We need to, vintage. There you go. So try to reuse, recycle, repurpose, reread. I think that's a lot better for the universe. Honestly, at the moment. So let's try to see what we can do for that. We'll see you all later. Yeah, I'll end this. I'll see you guys later. Bye.
This public service announcement is brought to you by Rotten Studios. Remember, no contact is the road to freedom.